Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. We are still learning chemistry form 3. The topic is the mole and the subtopic is the empirical and molecular formula. In the previous lesson, we were learning about the empirical formula, and we said that the empirical formula is a formula showing the simplest whole number ratio in which the atoms are combining in a compound. And we did several examples to show empirical or how to calculate the empirical formula. In this lesson, I want us to concentrate on the molecular formula. Molecular formula. What do you think is the molecular formula? We say that the molecular formula is a formula that shows the actual number of atoms or the actual number of each kind of atoms present in the molecule of a compound. A formula showing the actual number of each kind of atoms present in the molecule of a compound. Formula that shows the actual number of each kind of atoms present in a molecule or a compound. That is what molecular formula is. Therefore, it is easy to get the molecular formula when the empirical formula is known. It is easy to calculate or to get the molecular formula when the empirical formula is known, and we use this relationship that the empirical formula into brackets, that is N is equals to molecular formula. In this case, where N is a whole number, where N is a whole number, then when we talk about a whole number, then N can be 2, 3, 4, 5, 6, and so on. Therefore, you can get the molecular formula when you know the empirical formula, then because molecular formula is usually a multiple of the empirical formula. Molecular formula is the multiple of the empirical formula. Therefore, that's why N is a whole number. Therefore, it means that the empirical formula will be multiplied by 2, by 3, by 4, or by 5 to get the molecular formula. I want us to do some examples. The first example that is the example number 1. It says hydrocarbon was found to contain 92.3% carbon and the remaining is hydrogen. If its molecular mass is 78, determine its molecular formula. This is how we go about about it. Therefore, we have carbon and hydrogen elements which are combining. A hydrocarbon, I told you previously, is a compound of carbon and hydrogen elements only. Then the percentage composition of carbon is 92.3 and the remaining is hydrogen. Therefore, the percentage of carbon is 92.3 and the percentage of hydrogen is 100 minus 92.3. Therefore, 100 minus 92.3, that is 7.7. That is the percentage of hydrogen. It is 7.7. The relative atomic mass of carbon is 12, of hydrogen is 1. Therefore, if you divide, you are going to get the ratio in which they are combining. This is 92.3 divided by 12. You'll get 7.6917. And this is 7.7. That is the ratio in which they are combining. Again, we divide by the smallest. The smallest in this case is 7.6919. 7.6919. Therefore, when you divide this, you'll get 1. And that you're getting 1.0010. That is just equivalent to 1. Therefore, the ratio is 1:1. This is now the simplest whole number ratio. We have just rounded it off to the nearest whole number. The nearest whole number is 1. 1.0010. The nearest whole number is 1. Therefore, the ratio in which they are combining, the ratio in which carbon and hydrogen are combining, is in the ratio 1:1. Therefore, the empirical formula is CH. That is the empirical formula of that hydrocarbon. Therefore, we say that you can get now the empirical, you can get the molecular formula from the empirical formula using this relationship. So, N is equals to molecular formula, which is 78. The molecular formula is 78 in this case. And therefore, the empirical formula, which is this, then into brackets, then N outside, then that gives you the relative formula mass or the molecular mass of this hydrocarbon. Then we now get the products, or we sum up the molecular masses or relative atomic masses of carbon and hydrogen. Then carbon is 12. Then you add hydrogen, which is 1, into bracket N is equals to 78. And therefore, this is 12 plus 1, that is now 13N is equals 78. We now get the value of N. N will be given by 78 divided by 13. Therefore, N is equal to N is equals to 6. The value of N is 6. And therefore, the molecular, you just come and substitute N. If N is 6, then you substitute, then this will now give you have 6 carbon atoms and 6 hydrogen atoms. And therefore, the molecular formula is C6H6. That is how you go about it. Once you get the empirical formula, then you use this relationship. The empirical formula, the molecular formula is just a multiple of empirical formula. Then you have n. Then remember again, we say that n is supposed to be a whole number. That is why we have gotten n as 6. Then you get now the relative atomic, you sum up the relative atomic masses of the empirical formula. Then the mass of carbon, or the relative atomic mass of carbon, is 12. Relative atomic mass of hydrogen is 1. Therefore, this is now 12 plus 1. That is 13. Then all this is now equal to the formula mass, or the molecular mass of the hydrocarbon. So if it's now equal to the molecular mass, then now you get the value of n as 6. Then once you get the value of n as 6, you just substitute here, and then this now gives you you have 6 carbon atoms and 6 hydrogen atoms in the molecular formula, and then that gives you the molecular formula of that hydrocarbon. I want to give you the second example. This is the second example. That is the second example. So a compound of carbon, hydrogen and oxygen contains 54.55% carbon, 9.09% hydrogen, and 36.6% oxygen. If the relative molecular mass is 88, what is its molecular formula? Therefore, we need first to calculate the empirical formula. This is how you are supposed to go about it. You have carbon, hydrogen, and oxygen. The percentage composition carbon has a mass, or the percentage is 54. .55. Hydrogen, mass is 9.09. Oxygen, the percent is 36.6. Percentage of carbon is 54.55. Percentage of hydrogen is 9.09. Then percentage of oxygen is 36.6. Then we now divide by the relative atomic mass. Relative atomic mass of carbon is 12, of hydrogen is 1, and relative atomic mass of oxygen is 16. Then when you divide carbon, you're getting 4.5, 4.548. 4.54. Then this is 9.09. 36.6 divided by 16, you get 2.2875. Then at that level, therefore this is the ratio in which those elements are combining in that compound. Therefore, you divide by the smallest, and the smallest among the three is this 2.2875, 2.2875, and 2.2875. This is 1, 4.5. Get this as 1.9, 1.9877, 7. This is 3.9738. So we said once you get a 0.9, then round it off to the nearest whole number. Then now this, when you round this off to the nearest whole number, it will be 2. When you round this off to the nearest whole number, it will be 4. Then this will remain to be 1. Therefore, this is the simplest whole number in which these elements are combining. And therefore, the empirical formula is C2 H4, then O is just one atom. And therefore, that remains to be the empirical formula. Therefore, the molecular formula will be given by the empirical formula. You multiply by a certain whole number. Therefore, the mass is 88. The mass of this compound, or this compound is 88, which is now equal to, the empirical formula is C2 H4 and O. Then you multiply by a certain whole number. This is 88. It's equals to, add these ones together. The mass of carbon is 12. There are 2 atoms. Then you multiply by 2. You add, the mass of hydrogen is 1. There are 4 atoms. Then you multiply by 4. Then you add the mass of oxygen, which is 16. Therefore, this is 88. Then there is N. 88 is equals to 24 plus 4 plus 16. Therefore, 88 is equals to 24 plus 16. That gives you 40. Then 40 plus 4 gives you 44. Then it's now 88 is equals to 44N. And therefore, N is equals to 88 divided by 44. Therefore, N is equals to 2. Then if you substitute N, C2H4O, substitute with N. Now this gives you carbon atoms. Now you're substituting by 2. Then carbon atoms will now be 2 times 2, which is 4. Then hydrogen atoms will be 2 times 4, which is 8. And oxygen atoms will be 2 times 1, which is 2. And therefore, the molecular formula is C4H8O2. That is the molecular formula of the organic compound, or this compound of carbon, hydrogen, and oxygen. That is how you go about that calculation. I want to give you the last example. That is the third example. An organic compound has a relative formula mass of 90 grams. The relative formula mass is 90 grams. A 7.5 grams sample contains 3 grams carbon, 0.5 grams hydrogen, and 4.0 grams oxygen. Then determine its molecular formula. We start by calculating the empirical formula. So we have 3 elements: carbon, hydrogen, and oxygen. Their masses: carbon has a mass of 3 grams, hydrogen 0.5 grams, and oxygen 4 grams. Then the relative atomic mass, we divide by their relative atomic masses. Carbon, the relative atomic mass is 12. Hydrogen, the relative atomic mass is 1. And oxygen, the relative atomic mass is 16. Therefore, 4 divided by 16. If you divide 3 divided by 12, this will give you 0.25. 0.5 divided by 1 will give you 0.5. And 4 divided by 16 will give you 0.25. This is the ratio in which the 3 elements combine. Therefore, you divide by the smallest between the 3, which is the smallest, and the smallest is 0.25. So divide now all of them by 0.25. Divide by 0.25. Divide by 0.25. This is 1. You get 2. You get 1. Therefore, this is the simplest ratio. Therefore, the empirical formula is CH2O. That is the empirical formula. Or that is the simplest whole number ratio in which the 3 elements are combining in that organic compound. Therefore, the molecular formula is given by the C2, then multiply by N. The molecular mass of this hydrocarbon is 90. Then when you sum them up, this is 12 plus 1 times 2. That is the mass of hydrogen. And plus 16 is the mass of oxygen. Then multiply by a certain number, then it's going to give you 90. Therefore, this is 90 is equals to 12 plus 2 plus 16, which is multiplied by N, gives you 90. Therefore, this is 90, which is equals to 12 plus 2 is 14. 14 plus 16 is 30. Therefore, 90 is equals to 30 N. Therefore, N is given by 90 divided by 30, where N is equals to 3. N is equals to 3. And therefore, just come here and substitute the value of N. And therefore, CH2O, substitute by 3. Therefore, molecular formula will be 3 times 1 carbon atom. Then it will be C3. You'll have 3 atoms. Hydrogen will be 3 times 2. You get 6. And oxygen, 3 times 1, you get 3. Therefore, C3H6O3 is the molecular formula of the organic compound. And that is how you go about those questions. Therefore, ensure that you are able to calculate the molecular formula of compounds. Then you start by calculating the empirical formula. Then once you get the empirical formula, then use this relationship that the empirical formula, you multiply with a certain number, then that number is a whole number, then it's now going to give you the molecular formula. And it is that easy. I want to leave you with this assignment. That is the assignment. The first question is, a chloride of sulfur was found to have a relative molecular mass of 135 grams. A 5.4 grams sample of the chloride was found to contain 2.84 grams of choline. Determine the molecular formula of the chloride. Then the relative atomic mass of choline is 35.5 and sulfur is 32.0. The second question is, a hydrated salt of copper has the formula. There is a formula. About 25 grams of the salt was heated until all the water evaporated. If the mass of the anhydrous salt is 16.0 grams, then find the value of N. The value of this N is now the N on the salt. Then the relative atomic mass of copper is 64.0, sulfur is 32.0, oxygen is 16.0, and hydrogen is 1.0. The third question, on complete combustion of 1 mole of a certain alkane, 2 moles of carbon dioxide and 3 moles of water were produced. Then determine the relative molecular mass of the alkane. Relative atomic mass of carbon is 12.0, hydrogen is 1.0. And the last question is question number 4. If 7.36 grams of a compound decomposed to produce 6.93 grams of oxygen and the rest hydrogen, if the molecular mass of the compound is 34 grams, then determine the molecular formula of the compound. Then hydrogen has a mass of 1 and oxygen has a mass of 16. Therefore, ensure that you've attempted those questions before we meet in the next lesson. In the next lesson, again, we'll do some of these questions and I will give you some more questions for you to answer. Therefore, let's meet in the next lesson.